Visible.
So, hello everyone. I'm here to present our work on our work on the implementation of automated text summary using minimum dominating set theory. So basically, we are exploring a new way, a fundamentally new way of summarizing a text file. So the theoretical workflow of our process is that first we take input a text file and then represent it as a graph in such a way that each sentence is the vertex in that graph, and the contextual similarity between any two sentences is the edge between those two sentences. So to determine this contextual similarity, we use the concept of word embeddings. So, word embeddings is a way to map natural language words to a vector of real numbers in such a way that those vectors capture the natural language meaning of that word. So, for example, here, if we represent words like man, woman, king, and queen in a three-dimensional space, this is something that it might look like. So if we say here that the word man and woman are very close in meaning because they differ only in the gender of that particular quantity, but if we see the distance between words like man and queen, they differ not only in the gender of that object, but in the royalty status and other characteristics which are associated with those words also. So this is basically how word embeddings work. So to train word embeddings, we use a neural network of this architecture, and we deal with two types of words here: the train words and contextual words. Train words are those words for which we need to determine the word embedding, and contextual words are those words which occur in and around the target word. So, for example, here, if we have a sentence such as Ram is an honest person, and we need to the determine the word embedding of the word honest. So the target word here would be honest, and the contextual words would be Ram is and person. So after defining the target word and the contextual words here, we input the contextual words in this neural network and train the neural network in such a way that the output is a target word. So after training the neural network, we retain only the right half of this neural network to determine the word embeddings. So after we determine the word embeddings of words, we we come to a next concept here, which is the minimum dominating set. So since we want a generated summary to be as short as possible and at the same time be representative of the whole text, we use the concept of minimum dominating set here. So what is the minimum dominating set? In graph theory, minimum dominating set, uh, uh, a dominating set is a set of all those vertices in a graph in such a way that for each vertex, either the vertex is in that set, or it is adjacent to at least one vertex in that dominating set. So as you can see here for this given graph, the set of vertices A, G, and E is a dominating set. But as you may notice that the dominating set for a graph may not be unique, because we can also have a set of all vertices, and this would comply with the conditions of dominating set as well. So what we require here is the concept of minimum dominating set here. Minimum dominating set is a dominating set which has the fewest number of vertices possible. Similarly, we define the concept of minimum dominating set and dominating set for weighted graphs, where instead of using the concept of adjacency, we use the concept of the summation of weights here. We do not need to know the specifics here. So, for example, if we have a room here, and we need to place a Wi-Fi router in each of the five places: one, two, three, four, and five. So, and the edges represent that if we place a Wi-Fi router at the point one, the Wi-Fi signal can reach the points one, two, and five. And similarly, the whole graph is defined. So our problem here is that we need to place Wi-Fi routers in such a way that uh, all the places received internet access, and as well as we need to minimize the number of Wi-Fi routers. So here we use the concept of minimum dominating set, and after we determine the minimum dominating set for this graph, we can see that either we can place the Wi-Fi router at 1 and 3, 1 and 4, and so on. So this is the concept of minimum dominating set. So how we use this in our text summarization is that we represent our input text file as a graph, and we determine its minimum dominating set. So essentially what we are doing is when we determine the minimum dominating set of that graph, we are summarizing that text document. And, and so a brute force approach to summarize the document using this method is that we determine all the configurations. Here a configuration is a binary string of n of length n, where n is the number of vertices in the graph, and if an element is one, then it means that that vertex is in the minimum dominating set. Otherwise, it is not. So for a given configuration, we determine this score, the beta score here, which is which is used to determine the best minimum dominating set for our representation. Here, the Kronecker symbol, the definition of the Kronecker symbol is given here, and so is the Heaviside function here. And the roots of this formulation is in the statistical physics concepts, of which we do not need to know further. And so our algorithm, a brute force algorithm, would be to iterate over all the 2 raised to power n configurations of the graph, and then calculate the score, beta score for each configuration, and then determine the best configuration for our graph. But this is an exponential time algorithm. So to optimize it a little bit, we fix the size of the summary we require, and iterate over only those configurations which have a fixed number of vertices in the dominating set. So we use this, and we summarize our text file. We have two cases here. Either a text file is small. A small text file means that there are less than or equal to 100 sentences, or a text file is large, i.e. more than 100 sentences. So for a small text file, we we apply this optimized formulation directly and determine the summary. But for large text file, we have two approaches. Either we group multiple sentences in a node instead of having only one sentence in a node, or we divide the large text file into multiple short text files according to its sections. So while uh, while while implementing our algorithm in both the ways, we found some advantages and disadvantages. So the main disadvantage of the multiple lines in a node approach is that there might be some contextual inconsistencies in a node. For example, if there are two adjacent sentences which occur in different sections of the text, then they might not be consistent, because they represent because they might be talking about different topics of the text. So to deal with this disadvantage, we have our approach of dividing the large text file into multiple short files, and generating and applying the algorithm for the short text file for each short text file, and combining all the sub summaries into one whole generated summary. So after we implemented our algorithm on various text files, and we evaluated our results against uh, against the publicly available summarization tools, and we found we came to we concluded two things. That first, our algorithm performed marginally better in uh, marginally better than the publicly available tools. And the second advantage of our algorithm is that the tools publicly available now, they have a word limit on an input text file of how much text file of how large a text file can be. But our algorithm has no such limit, and so thus and so we can apply it practically also. The only disadvantage of our algorithm is that the upper limit of our algorithm is very high. That is 5 minutes of it can take up to 5 minutes to summarize a text file, depending upon the text file and all. So, with further optimizations, I believe we can better this algorithm also. So, uh, uh, so this is our algorithm. So, does anyone have any questions there?
Thank you. Wonderful presentation. Do we have any questions? Yeah. Can you can you just tell me of the results point of view, like implementation point of view, Alan?
Sorry, I didn't. Sorry, you are not audible.
Implementation point of view.
Yes. What do you want to know?
Can you talk on the implementation of the of your paper point of view, like
Uh,
the results and implementation? Uh, yeah,
you want to see the generated summary and all.
yeah. Do you
So,
have anything right now? To show?
can I share my code with you?
You can,
Should
if
I?
possible. If not, not required because it's
So,
open
so,
platform.
I have my code here. 1 second here.
Yeah.
Here I have. Is my screen visible here?
Yes.
So I took an article on black hole from Wikipedia, and the file Black Hole for Kids is the human generated summary for that black hole file. So after implementing this code, so this is the whole text file here, black holes and all.
Okay.
Yeah. Mm. And this is a summary. This is the summary text, which is the human generated summary here. Uh, Once. This is our generated summary here. Basically, these are 4 sentences which are most representative of the whole text file of our input text file. So it talks about the event horizon, the temperature of the and all that. And we have compared our results also here. Print summarization this is the similarity between our generated summary and the human generated summary here, 99.7%. We achieved a score of 99.7 here in this.
Have you done any other trials also? Only one sample you did?
I have other approaches, as I mentioned, in the multiple sentences in a node and all that. Let me just. This is the approach where we divide a large text file into many shorter text files. So this is the whole article. This article is on artificial intelligence. This is the Wikipedia article.
Okay. Okay.
And here we have evaluated the quality of a generated, and 99.5% score we have. That is, our generated summary is 99.5% similar to the human generated summary of that article.
That's great. Nice. Thank you. Anybody have any other questions to talk? Ask her?
I have one question. Yeah, my name is Praveen.
Yes.
I am also working in the same organization, Stony Brook University, Korea campus. So two of my students are presenting today. I have a
Yes.
question about this. Yeah, thanks, Alin, for the nice presentation. So my question is as follows: do you use abstractive summarization or extractive summarization?
Extractive. We are using extractive here. we are picking out the sentences as we have determined in the minimum dominating set. Basically, we represent the graph as a we represent the text file as a graph, and we pick out its minimum dominating set and use those sentences which are in the minimum dominating set of that graph.
Okay. So my question is, when you say the cosine similarity, so how accurately it represents your summarization?
The cosine similarity is only the method to determine the similarity between two texts. So what we are trying to infer here is that our generated summary is very similar to the similarity which a human would generate for that same text file.
Okay, fine. Yeah, thank you. Thank you very much. Yeah, I got it. Yeah, yeah, thanks, sir.
Any more questions, sir?
No more questions from my side. Thank you.
Thank you, sir. Thank you.
Okay. So thank you for having me here, and it was wonderful to present here in front of all these researchers.
Yes, thank you. Thank you for
Thank
your
you.
presentation and good work.
Mm.
We'll go to our next presentation of the day. We have Zanab